Hello, folks. This is Mr. Walk here, coming to you with our video for our next part of our notes. We are talking about perpendicular bisectors this time. So, what is a perpendicular bisector? Each segment in a plane has only one bisector. Now, remember, bisector means that it's cutting in half, and that bisector is also perpendicular to the segment. This line is called a perpendicular bisector. So every line that we're going to be dealing with has exactly one of these lines that'll cut it in half and meet it at a right angle. All right, how do we make a perpendicular bisector? First off, draw the segment. So we already have that done for us. Now, with your compass, you're either going to use your metal compass or your sliding compass. We're going to put our compass on one side of the segment, and we're going to open up to be a little more than half of the width. So here's my slider. I put our circle on one end, and I want to slide it so it's a little more than halfway. So we're eyeballing it a little bit. That's perfectly fine. All right, so this is a little more than half. Now, our instruction says we are going to swing an arc above and below the segments, and then we're not going to adjust this, so please make sure you pay attention to that. So I swing it above. So here's a little arc above, and we come below, a little arc below. Now, if you connected this and you just made a big arc like this, that's also fine, okay? Now, not changing the size, we come over here, and we make an arc above and below the segment. Sorry about my hands being in the way. So, once we have those two arcs above and below, we draw a line through the intersection of both of these arcs. So, line up your ruler and draw your line. And then just to check it, so we make sure that we're all aware, this line was originally around a little bit like a 2.75. This is around half of that line. If I actually check with the centimeter side, that might be a little easier. All right, so 6.5, 6.6, and 3 point. Yeah, that works. Okay. All right, thanks for watching, people. Facts of this. All right, the perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of a triangle. This is called the circumcenter. So in this triangle, I have about 3 lines here that are all perpendicular bisectors of their respective sides. These all meet here at this center point. This point here is the same distance away from each of the corners of this triangle. It's the same distance away from A, B, and C. So if that's the case, this helps us set up any algebra that we might have concerning this. All right, jumping into some more things that we got to talk about some other things that we'll need to know concerning this. So first off, we have the perpendicular bisector theorem. In a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So that means that if this point or any of these points that are on the line are the same distance away from the ends of these segments or any of these parts here on the sides. So they're all the same distance away from the bisector. Now the converse is when we have a point that is equidistant from the endpoints of a segment, then that point is on that bisector. If I can see that that point is cutting that segment in half, that means that if I really wanted to, I can make a bisector that goes through it that will be perpendicular. Now, the last thing that we got is concurrency of perpendicular bisectors of a triangle theorem. So this is specific to a triangle. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of a triangle. So if you have the circumcenter, you should know that it is equidistant from any of the vertices for the triangle. Okay, so hopping back into this, we got a little bit more algebra coming in, but we want to make sure that you are aware. You want to draw yourself a triangle. Try to make your bisector on your own. I want you to try it out. Make sure that you go through and see it. Now, depending on the type of triangle you got, you're going to notice something different as you're going to go through and make the bisectors and find what the circumcenter is. If you were looking at an acute triangle, the circumcenter is inside of the triangle. If you're looking at a right triangle, the circumcenter is on the hypotenuse of the triangle, aka that's the side that is across from the right angle. Now, if you drew an obtuse triangle, that circumcenter will be outside. So, depending on which triangle you draw, you will have a different location for where that point is. Okay, now back to our good old friend algebra. Like I told you before, a lot of algebra in geometry is in the context of a picture. So what we have here is a perpendicular bisector, AB, and it is bisecting CB. They want us to find on this the length of AC, and then they want us to find CD. So first thing I need to know is that because this is a bisector, I can set any of the points equal to each other because they are all equidistant. So I can tell that both these sides for AC and for AB are equidistant from the bisector. So that means I can set them equal to each other. So I set these two equal. I start to solve it. I bring over the 7 to the other side, giving me that negative 2y equals negative 12. I divide both sides by negative 2, telling me that y is 6. But we're not done yet. We got to take that 6 and we got to plug it back in to the side for AC. That side is the 7y minus 12, which will give us 30 if we plug that 6 back in. For the other side, if I'm trying to find CD, remember, CD is down here, and I know that this side and this side are both equal. So I can set those both equal to each other to solve it for x. So I go through, I move my 9x to the other side, I move my negative 9 to the other side by adding it. This will give me that x is 2. But just like with the last one, this is not the end of it. I have to then take this and plug it back into CD. So CD is the 4x minus 9, not 4x, 14x minus 9. So I'm doing 14 times 2 minus 9. This should give us 19 for what we have. All right, people. You're going to make sure that you get this into your book and follow up for our next lesson, which is going to be over angle bisectors. Have a good day.